Okay, for this final, I hope quite short video, I just want to go through and reiterate, reiterate a main message about sort of the exact wording of questions and how to interpret. But also then I'll just give you a couple of hints the way that I approach a pedigree, which I think is quite helpful and could save you a lot of time. Okay. So as I've been saying, I've said this a few times, so I probably don't even really need to repeat it, but just that sometimes there are many possible, several possible modes of segregation that could be the case. And so the best interpretation is the one that requires the fewest of those kinds of assumptions, right? So in this case, we've got a pedigree. It must be recessive. There's no question about that. So be sure you can explain why. Put it down in your notes. How do you know it's recessive? Now, it could be an autosomal trait or it could be an X-linked trait, and you can draw in the genotypes if it was autosomal, right? Then those would be those genotypes. If it was on the X chromosome, then these would be the genotypes. Mom would be heterozygous and dad like this. And then, right? So you can make it work either way. It's possible for this to be autosomal or X-linked recessive. And then X-linked is the more likely, and you want to explain why. Okay, and if that's confusing, we will go through it probably in the class, but do ask if you're not sure. I've been going on about this stuff quite a bit, so I'm kind of, I don't want to bore you out of your mind. But if you can answer these questions easily, great. And if you can't answer them easily, please work with your TA. Do lots of practice questions in any textbook on pedigrees. Okay, now I just want to briefly mention Y-linked genes because there are a very small number of genes on those on the Y chromosome. For the most part, most of them don't have a counterpart gene on the X. X's and Y's appear like homologs, and the regions of the chromosomes at the very tips are similar, so there could be a couple of genes that are the same out on those tips. But the Y-linked genes are actually ones that are on the Y chromosome, and there is no corresponding gene on the X. And so these ones, I wasn't touching anything when that switched, so I don't know what's going on. These are things where we see father transmitting the condition to all his sons and never to the daughters, and over multiple generations you just never see it in the daughters, individuals with two X chromosomes. And in that case, and there are a couple of historical cases of conditions that are Y-linked, but they're super rare. So for the most part, we won't be focusing on them, but it's always something to keep in your mind. What pattern would you expect to see? Explain, how that would work. Okay, so this is the approach I recommend. So I want you to assume that the trait is very rare unless I say 1 in 3 people, have this condition or something. Then it would not be rare at all. And if it is rare, I want you to assume that everybody marrying into that family is homozygous normal, or having children with. I guess it's kind of silly to think it has to be marriage. But anyway, just assume that anyone, coming in is homozygous normal, unless there's evidence, and you can't actually, it won't work unless that person is heterozygous, right? And then assume it is a dominant trait. The first thing I do is assume it's a dominant trait and look for evidence that it's not dominant, okay? And then I assume it's X-linked and I look for evidence against that. Okay, yeah, and again, the most likely mode of inheritance is going to be the one that requires the fewest assumption. I have somewhere, and I'll dig it out closer to the time that we actually have this lecture in class. This is a week and a bit in advance. I will have some opportunities for practice. I'll have like a PowerPoint presentation, and it'll have a pedigree, and then it'll say recessive or dominant, autosomal or X-linked, and and then it'll go through, and you can sort of do self-testing along the way. And we'll probably have some practice questions and tutorials too. Okay, so assume it's dominant and then look for evidence against it. This is the kind of evidence we're talking about. Unaffected parents who have an affected child. Okay, and then assume it's on the X chromosome and look for evidence against it. This is a good example. This is evidence against X linkage because the daughter is homozygous for the condition. Father is not passing on that mutant allele, and he would be showing it if he had it because he only has one X. Other evidence against it would be something like, maybe you've determined that it is in fact a dominant trait. These are very badly drawn. I'm sorry. There's a sun that's supposed to be a square. And you've got two daughters that have the condition, but two daughters who don't have the condition. If we know it's a dominant trait, suppose you have no evidence against it being a dominant trait, but you see this, here's a father passing it to two daughters. Okay, that looks like it could be on the X chromosome, but wait a minute. What about this daughter? She would have gotten that X too, and so would this daughter. So that's evidence against X linkage too. Or a mother who's affected, and we've decided it's a recessive trait, so we know that first. And so we think recessive, okay. And then, there's a son with it. There's a son with it. Oop, and there's a son who doesn't have it. So if it was only these individuals, then we'd say, oh yeah, it probably is X-linked recessive. But we have a son who isn't affected. So if mother is homozygous for that allele, we've decided it's recessive already. So if it was on the X, she'd have to have this genotype. But this is the guy who shows us that that's not the case. It must be an autosomal trait and not an X-linked trait, right? And so this is about just looking at the patterns of segregation. And I've always found this to work really well. Sometimes there's still a lot of, oh, I don't know, trying to figure out how it works. But if you first assume it's a dominant trait and you can't find any reason why it can't be dominant, go with that and then look for evidence, then assume it's on the X chromosome and see, if you can find evidence against that. And that, to me, is the quickest and most efficient way to deal with the pedigrees. Okay? And please don't give memorized or general responses. A lot of people will just try to memorize all the pedigrees they've seen and things like that. And things like seen more frequently in males than females. No, this is an example of the good, in this pedigree, there's an affected female, whatever the number is, with an unaffected father, therefore the trait cannot be recessive X-linked, a careful and really specific. Imagine you're making a legal case in court that proves you understand. This, I don't know if you understand. This, I totally know that you're talking about a specific individual, and her father doesn't have it, and therefore, and you could even draw the chromosomes, the genotypes and so on. And that's how you convince us that you understand. Because we're not looking to deduct points. We're not looking to penalize. We're actually just looking for places where we can give credit. That's our approach to grading. So show us how we can give you credit. Don't leave us guessing, because if we have to guess, we can't assume that right? Okay, and that's it. We will see you in lecture.